Okay, so for this problem, we're trying to figure out the probability of a randomly selected can being over 12.1 ounces. So they give you the population mean, which is 12 ounces. They give you the standard deviation, which is 0.16 ounces. So the first step you need to take is to find the z-score. In order to do that, you take the x value 12.1 and subtract the mean, which is 12, and divide that by the standard deviation, and you'll end up with 0.625. So that is your that is your z-score, which means how many standard deviations the value is away from the mean. And so that just means that you're testing the probability of x being greater than 12.1 or the probability of z being greater than 0.625. So then in order to figure out that probability, you can use norm CDF in your calculator and plug in negative 9,999 or negative infinity, 0.625, which is the z-score, 0, which is the mean, and 1, which is the standard deviation for a normal distribution. And you get 0.734, but that's not our answer because that would be the probability of selecting a can less than 12.1 ounces. So you have to subtract that number from 1 and you get 0.266, which is the probability of selecting a can larger than 12.1 ounces. And then for problem 9, you're trying to figure out which value separates the top 5% from the rest of the values. So you're finding probability of 95% or 0.95. And to do that, there are two ways to do it. You can use your calculator, and that's very easy. All you do is use inverse norm and plug in 0.95, which is the value they gave us, 12, which is the mean, and 0.16, which is the standard deviation, and you end up with 12.26. Or if you wanted to do it by hand, you could find 0.95 in the Z chart, and when you do that, you find 1.645, and you'd multiply that by 0.16, which is the standard deviation, and you'd get 0.2632. And you just add that value to the mean, which in this case is 12, and you end up with the same answer, which is 12.26.